Hi friends, welcome to my YouTube channel Learn Commerce with Namita. I am Namita Mane. In today's video, let us start with a new topic, that is linear programming problem, LPP. So first we'll try to understand what is LPP. Then we'll see definition of LPP, methods to solve LPP, and 4 important components in LPP and one example. So all this we are going to learn in this lecture. So without wasting time, let's start the lecture. So first, linear programming problem, LPP. Introduction. What is linear programming problem? So linear programming is a mathematical technique. It is what? It is a mathematical technique for determining the maximum utilization of available resources in a manufacturing process or in business concern. So linear programming is a technique which is used to determine the maximum utilization of available resources in manufacturing process or in any business. Now in linear programming there are two terms. First is linear and second is programming. So what is the meaning of linear? So the term linear is used in the sense, the term linear is used in the sense of a straight line. Okay, linear means what? A straight line and a proportional relationship of the interrelated two or more variable, which is known as linearity. Okay, so the term linear is used in the sense of a straight line and a proportional relationship of the interrelated two or more variables, which is known as linearity. Next term is programming. Now programming refers to the mathematical method used for a planning, a way of action. So programming is what? A way of action to achieve a desired results in a manufacturing process or in business concern. Mostly planning, programming is what? A way of planning or way of action in a systematic way to achieve a result. It can be, or it means that maximization of cost or minimization of profit. So this is the meaning or introduction of LPP. Next we'll see the definition of linear programming. So the definition of linear programming is a technique. Okay, so linear programming is a technique which is applicable to those programming in which the desired objective as well as the restrictions on the resources give rise to a linear functions. So this is the definition of linear programming. Now next we'll see the methods. There are two methods to find or to solve linear programming problem. So methods to solve linear programming problem is, first is formulation method. Now formulation method is what? In this method we formulate the problem into equation. Next is solution. In solution method there are two methods, okay? Graphical method and simplex method. These two methods we can formulate or we can solve it by using graph paper. So in the formulation method, we formulate the problem into equation, and in graphical method and simplex method the equation is solved with the help of graph. Okay, so this is the introduction of linear programming problem. Copy down in your notebook. Okay, so now next we'll see the formulation of LPP. Now in formulation of LPP there are 4 most important components. With the help of this component we can formulate the LPP or we can find the linear programming problem. So components are, first is decision variable, next is objective function, third is constraint, and fourth is non-negativity constraints. So non-negative constraints means it is also called as physical constraint. So there are 4 components. Okay, first is decision variable, objective function, constraints, and non-negativity constraints. With the help of this component we can easily formulate the linear programming problem. So let's see what is decision variable. Now decision variable Okay, now in the formulation of linear programming problem, one has to decide the unknowns. Okay, these unknowns one has to find out. Okay, so this is called as decision variable. So the quantities, okay, so the quantities that needs to be determined in order to solve the linear programming problem are called as decision variables. So the quantities that needs to be determined in order to solve the LPP are called as decision variable. Next component is objective function. Okay, this is important. What is objective function? Now the goal or the objective to be achieved, okay, the goal or objective to be achieved is called as objective function. Now objective functions is what? The linear functions, okay, the linear functions of the decision variable. So the linear functions of the decision variable which is to be maximized or minimized, or you can say the objective or the goal which you have to minimize or maximize is called as objective function. So the linear function of decision variable which is to be maximized or minimized is called as objective function. Now example, this objective function is denoted as Z. Okay, it is denoted as capital Z. Now Z is equals to ax plus by. Okay, objective function Z is equals to ax plus by, where AB, okay, AB are constant. Okay, AB are constant. This AB which has to be maximized or minimized, and variables x and y, okay, x and y are called as decision variable. So objective function is nothing but a linear function of the decision variable which is to be maximized or minimized is called as objective function. So what is the goal to achieve? Okay, whether it is to maximize the profit or minimize the cost, we can find with the help of objective function. So Z is equals to ax plus by. Okay, and this a and b is constant and x and y are nothing but decision variable. Now next we'll see constraints. Okay, constraints are what? Restrictions or limitation which the constraints are nothing but restrictions or limitation. So constraints is what? The linear inequalities. Okay, the linear inequalities or equation, the linear inequalities or equation or restrictions on the variables of a linear programming problem are called constraints. Okay, constraints, in order to achieve these objective functions, there are many restrictions. Okay, there are many restrictions, like suppose in a manufacturing company or in manufacturing process, you want to maximize your profit, okay, for particular product. Now there will be many restrictions, like there will be less labor, raw material will be not available. So these are what? Restrictions in order to achieve the profit. So constraints are restrictions or limitations. Okay, next is what? Non-negativity constraints. Non-negativity constraints are what? Physical constraints. So non-negativity is what? The inequalities. Okay, the inequalities x greater than equal to 0, x greater than equal to 0 and y greater than equal to 0 are called non-negativity constraints, because x and y are what? Decision variables. So this x and y, usually you take the x and y as number of items produced, and number of items cannot be a negative number. Okay, so if in a manufacturing process you want to manufacture television, okay, TV or mobile phone, so this mobile phone cannot be in negative like -1 or the -2 and so on. So this production is always in positive. That's why x is greater than equal to 0 and y is greater than equal to 0. So these are called non-negativity constraints. It is also called as physical constraints. So I will repeat again, x and y are usually the number of items produced. So this number of items you cannot produce a negative, okay? You cannot produce in negative, okay? That's why always x is greater than equal to 0 and y is greater than equal to 0. Now next we'll see to formulate, okay? Now if there is a problem or in example, so the steps to formulate LPP, how you can find or solve or formulate linear programming problem. So first of all, you need to identify the decision variable. So this is step 1. Step 1 is what? To identify decision variable. Step number 2. Step 2 is identify the objective function. After identifying the objective function, now in objective function you need to find or identify whether you want to maximize the profit or minimize the cost. After that, step number 3 is identify the constraints, okay? So to achieve this objective function, what are the limitations, what are the restrictions, okay, or subject to means subject to achieve this objective functions, there are some limitations, there are some restrictions, okay? So identify that constraints or identify that restriction. And step 4 is what? Non-negativity constraints. Non-negativity constraints will be what? X comma y greater than equal to 0, because you cannot produce negative number of items, okay? So copy. I hope you have understood this formulation of LPP, very important. First identify decision variable, next identify objective function, then constraints, non-negativity, okay? And you can find the answer of LPP, okay? So we'll take one example to understand these 4 steps, then you will understand how to formulate LPP, okay? Linear programming problem. Decision variable, objective function, constraints, non-negativity constraints, okay? So by the time, copy down in your notebook and then we'll see one example. Okay, so now we'll see the example of linear programming problem, how to find or how to formulate linear programming problem. So this is the example of linear programming problem. Example number 1. Now in this example, okay, read the example and find out what we have to formulate, okay? So now in this example, there are 2 different kinds of foods, okay? So underline, first of all underline, and whatever numbers are there we are going to put in the form of table, and with the help of this table we will put it into the equation. That means we are going to formulate the problem, okay? So there are 2 different kinds of food, okay? There are 2 different kinds of food, food A and food B, okay? This is the first sentence. 2 different kinds of food A and B are being considered to form a weekly diet, okay? So this is a weekly diet problem. This is a weekly diet problem, and we have to formulate the LPP, okay? So in weekly diet there are 2 different kinds of food. So food name is A and food, second food is B, okay? The minimum, next is what? The minimum weekly requirement. The minimum weekly requirement of fats, carbohydrates and protein, okay? So in weekly diet we require fats, we require carbohydrates, we require proteins, okay? This minimum fats, requirement of fats, carbohydrates and protein is for weekly, okay? Weekly. So the minimum weekly requirement of fats, carbohydrate and proteins are 18, 24 and 24 units respectively. So fat 18, carbohydrate 24, proteins 24 units respectively. Okay, next sentence is what? 1 kg of food A. Okay, now see, 1 kg of food A, 1 kg of food A contains, okay, 1 kg of food A contains 4, 16 and 18 units of fats, carbohydrates and proteins respectively. So 1 kg of food A. First try to understand the question, okay, and understand the problem carefully. So 1 kg of food A. So first food is what? Food A. So per 1 kg of food A, it contains 4 units of fats, 16 units of carbohydrates, 8 units of proteins. Okay, next food B. Food B, 1 kg of food B, 1 kg of food B contains 12, 4 and 6 units of fats, carbohydrates, proteins respectively. So 1 kg of food B, it contains 12 units of fats, 4 units of carbohydrates, 6 units of proteins respectively. Now the price, okay, the price, next sentence. So first is this two different kinds of food A and B weekly diet. Second sentence is minimum requirement, weekly requirement. Third is per kg, okay, 1 kg of food A. Fourth is 1 kg of food B. Now fifth sentence, see, the prices of food A is 4 rupees per kg. So the price of food A, the price of food A is what? 4 kg. And B, the price of food B is 3 rupees per kg. Okay, next what we have to find? Find the quantity of food A and B. So find the quantity of food A and B to be purchased, okay, so that the total cost is minimum and the requirement is to be fulfilled. Okay, so formulate the problem as linear programming problem. So now in the last sentence they have said that find the quantity of food A and B which is to be purchased, and in order to minimize the cost, and in the minimum cost we should get the weekly requirement of fats, carbohydrates and proteins which is to be fulfilled, and we have to formulate the problem as linear programming problem. Now I have explained you to solve or steps to formulate linear programming problem. First we have to identify the decision variable. Next, second step, we have to identify objective function. Third is to identify constraints, and fourth is to identify that is what non-negativity constraints. Okay, now first this is a big question example. Now we have understood the question. Okay, the question says that this question, in short, it explains that it is a weekly requirement of diet, fats, carbohydrates and proteins, and we have to find the total cost, okay, which we minimize, and in that minimum cost we can fulfill the requirements and formulate the problem as LPP. Now easy, first of all remove all the numbers, okay, whatever is there, remove all the numbers and put in the table form, okay, solution. Now so I have prepared the table, okay. Now in this whole problem I am putting into a small table. With the help of this table we can easily find or formulate the equation, okay. So first, in the question what is given? Food is given, okay. So I have given the heading of my first column, food. Now how many types of food is there? Only 2 types of food is there. The name of the food is A, okay, so I have written A. Second is B, so B. Now weekly diet, what is to be required in the weekly diet? We require carbohydrates, fats, carbohydrates and protein. So fats, carbohydrate, proteins, okay, and price is given, that's why price column I have prepared, okay. Now food A. Food A, first we'll see food A, okay. 1 kg of food A. 1 kg of food A contains fats. How much fats it contains? It contains 4 units of fats. So write 4 units of fats. Then 16 units of carbohydrates, 8 units of protein, okay. And price of food A is how much? Price of food A, see the price of food A is rupees 4 per kg. So write the price of food A 4, okay. Next is what? Next is 1 kg of food B, okay. 1 kg of food B contains how many units of fats? It contains 12 units of fats. So 12 units of fats, 4 units of carbohydrates and 6 units of proteins, okay. Now the price of B, price of food B is how much? 3 rupees. So write 3 rupees under the heading price. Clear this much? So I have put all the contents, okay, carbohydrate, numbers of fats, requirements of fats, carbohydrates, proteins and price under in the form of table, okay. Now total weekly diet, okay, weekly requirement of minimum weekly requirement of fats, carbohydrates and protein is how much? 18 we require for fats, 24 carbohydrates and 24 units of protein, okay. So I have put all the values, all the numbers in the table. Now next, what is there? Find the quantity food A and B to be purchased so that the total cost is to be minimized and the requirement is to be fulfilled. Formulate the problem as linear programming, okay. So formulate, we are going to, there are 2 methods to solve a problem. First is formulation method and second is graphical method and simplex method. Simplex method is not in your syllabus. You have only formulation method and graphical method, okay. So we are going to formulate, and in formulation method what we do, we in the formulation method we formulate the problem into equation, okay. So we are going to formulate this whole problem into equation. So with the help of this table we can easily formulate in the equation, okay. So first, in the first step to formulate is what? To identify the decision variable. Second is objective function. Third is constraint and fourth is non-negativity constraint, okay. Now decision variables are what? X and Y, okay. So first what we'll give? Let X be food A, okay. So food A is what? X. Let Y be food B. Clear this much? Let Y be food B. So X is food A, Y is food B. So this is what? Our decision variable. So first step we have identified decision variables, okay. Clear? First step. Now second is what? We have to find the objective function. Now objective function is what? Objective functions means what? The goal, okay, to achieve the goal, whether it is to minimize or maximize. So here itself, here they have said that the cost, the total cost is to be minimum, okay. That means minimization of the cost. So the lower the price, the more the requirement is to be fulfilled, okay. So objective function is what? Z, okay. And what is objective function? What is what it is saying? To minimize, okay, in order to achieve the goal, okay. So minimize, okay, or you can write like this also, minimum Z, okay, anything, write full minimum z or z minimum. So what is how we can find the objective function, or how we can achieve the objective function with the help of the prices, okay, because if the prices are low, if the cost is low, then we can fulfill the requirement, okay. So z is equals to minimum z or minimum objective is equals to 4x, okay. So price of food A, clear, plus 3y. This is what our objective function. This is our objective function, clear. So price, if the prices are low, we can take more fats, carbohydrates and protein. So minimum, z minimum is equals to 4x plus 3y, okay. Why these x and y are what? Decision variables, clear. So we have considered x as food A and y as food B. So 4x, this is what we are formulating into equation. So this is equation 4x plus 3y, this is objective function. Now next is what? Step 1, step 2 is done. Third step is what? Identify constraints. Constraints are what? Limitations or restrictions which are stopping to achieve this objective function. So what are those? Okay, and the next step is what? Non-negativity constraint. So subject to is what? The constraint, subject to. In this way we have to formulate subject to. First constraint is what? First constraint, fats, food A, okay. First there are three this thing what? Fats, diet, minimum requirement of diet is fats, carbohydrates and protein. So first constraint 4x plus 12y, okay. 4x plus 12y, fats, we are taking this constraint. First constraint is fats, then carbohydrate and proteins. So fat 4x plus 12y greater than equal to 18, okay, greater than equal to 18. So we have to fulfill the requirement in this, okay. Next constraint, carbohydrates. So 16x, okay, like this, 16x plus 4y greater than equal to 24, clear. Next is protein, 8x plus 6y greater than equal to 24, clear. So these are what? Constraint. These are constraints which are stopping, or these are what? Restrictions which are stopping us to achieve this objective, okay. So 4x plus 12y greater than equal to 18, 16x plus 4y greater than equal to 24, 8x plus 6y greater than equal to 24 constraints, okay. Now third step is done, we have got constraint. Now we have to find non-negativity, okay. As I said, non-negativity constraint is also called as physical constraint, and this inequality, like x is greater than equal to 0 and y is greater than equal to 0. Why? Because you cannot produce the number of items, or you cannot take this proteins, fats and carbohydrates in negative number. That's why next is what? X, y is greater than equal to 0, and this is your non-negative constraint, okay. So this is the answer for this problem, okay. In this way you have to formulate the LPP, okay, for the problem. So minimum object decision variables are x and y decision variable, z minimum 4x plus 3y objective function subject to 4x plus 12y greater than equal to 18. 16 next is what? Carbohydrate constraint. 16x plus 4y greater than equal to 24. 8x plus 6y greater than equal to 24, and non-negativity is what? X comma y greater than equal to 0, non-negativity. Okay, in this way you have to solve the sum. Okay, copy down in your notebook. Okay, so I hope you have understood how to formulate linear programming problem. Thank you very much. Please subscribe my YouTube channel, like and share the video, and do not forget to press the bell icon to get the latest notification.